Another component of the steam system is steam turbines. I will just give you a short highlight of the steam turbine because we will have a specific chapter discussing this topic. So the steam turbines is used to convert the energy from the steam into the power. Okay, we need to know that not all chemical plant apply this thing. Okay, so another important usage of the steam turbine is that we can use the unit to produce power, electricity. So from one single utility sources, which is from the fuel, we can generate both utilities, which is the steams for heating in the plant, and we can also produce electricity that can be used to support the operation of the plant. Another usage of the why we need a steam turbine is we can use it to produce soft works as the prime movers for something that require that in the unit. One of the benefit of having steam turbines is also to have a step down pressure. Okay, so a step down pressure in the turbine system is inherent properties, because when we use the turbine, we always come out with high pressure steam, and the pressure come out at the low pressure steam. So why this is an extra benefit? Because if we don't have steam turbines and our boiler generate super high pressure, like up to 100 bar gauge, we will need some small valve, we call it as the pressure step down, to be able to lower the steam pressure so that it can be distributed in the steam distribution. So speaking of steam distribution, this figure shows a schematic of typical steam distribution system. So here you have raw water is treated before entering the boiler. Here this is a boiler feed water. Then we have the aerator unit, as we discussed earlier, some of the chemical dosing to further remove the dissolved gases, and then fuel is burned in a boiler to produce steam. So basically this is a steam, this is steam that going to the steam system, and some of the water in the boiler is let go through the blow down stream, as seen here. Okay, so the water is converted to the high pressure steam. HP here stands for high pressure steam, and then the high pressure steam can be directly used to run the steam generator here, or okay, the high pressure steam is let down here. This is a let down station through a back pressure turbine to the medium pressure, okay, this stream, and can also go to the low pressure steam here using a back pressure turbine here. Okay, alternatively, you can also have a let down station by using valve here to lower the pressure of the steam from the high pressure to the medium pressure steam, and from medium pressure steam to the low pressure steam here. That is a basic system for steam distribution. So some important remark is that the steam normally distributed with several pressure level. We have the three there: high pressure, medium pressure, and low pressure. So typical maximum steam heater distribution is around 40 bar gauge. Okay, the let down valve on the right side of the figure here, this is the let down valve. Okay, it's used to control the steam header pressure. with the boiler feed water injection for the de-superheating. And then the heat loss in the steam distribution system can be around 10 to 20% of the fuel fired in the boiler. So it is quite a lot. Okay, so some important thing in the steam distribution is it is more advantageous to use low pressure steam rather than high pressure. Why? Because of the higher latent heat can also be achieved at lower pressure. So it's even lower. If you look into the steam table, as I recommended in the earlier video, look into the two-phase diagram of the water at different pressure, you see that the latent heat at lower pressure steam is higher. Another one is that if you operate it at lower pressure, you can run the system with the lower capital cost for heat transfer equipment. Why? Because then at lower pressure, we only need a thicker tubes in the heat exchanger, for example. So the investment cost of the heat exchanger is lower. And let's say if your system is run, if your boiler produces steam at high temperature, you have an opportunity to use the power generation in the steam turbines that convert high pressure steam to the low pressure steam. So the last component of the steam system is steam users. So what are those users? The users are basically all operational units requiring steam. Those are the users. So some of the important remarks in the steam user is that at the lowest point of the steam heater, usually fitted with steam trap, this guy. So at lowest pressure, so when you take out the latent heat from the steam, you might have a condensation. So when we have a condensation, we would like to separate the condensate with the steam, and then the tools required for that one called as the steam trap. So the steam trap allows condensate water to pass out but prevent steam from leaving the system.